We already discussed the compound angles, compound angle identities, the compound angle identities, and then okay, let me list those. The first one is sine. You have sine A plus B, that will be equals to sine A cos B plus sine B cos A, something like that. And then the next one will be sine A minus B. This is equals to sine A cos B minus sine B cos A. The third one will be cos A plus B, which is equals to cos A cos B minus sine A and sine B. Then if you have cos A minus B, so in this case the negative separates the two compound angles. So in this case this identity will be cos A cos B plus sine A sine B, something like that. Then the other part that we have to look at is the double angle identities. The double angle identities. The double angle identities are developed from the compound angle identities. The first one that we have is sine 2A. Okay, sine 2A therefore will be equals to 2 sine A cos A. And then I send a picture of how this is developed, so you have to look into it on the other group. Sine 2A is equals to 2A, 2 sine A cos A. And then cos 2A, double angle for cos 2A has 3 identities. So the first one will be cos squared A minus sine squared A. Again, I showed how these are proved in the picture that I sent on the group, so you have to check that out. And then this is equals to 2 cos squared A minus 1. It's also equals to 1 minus 2 sine squared A. Okay, so these are the 3 identities for cos, for the double angle identity. Okay, in that case, let's look at one example. Prove that. So how do I prove that? I'm going to be using both my compound angles and my double angles identities. So in this case I have to choose which identities will suit or is necessary to be used during the proof. So I have to choose first of all the side. Which side am I proving first? Do I prove the left hand side going to the right hand side, or do I prove the right hand side going to the left hand side? So if I'm to prove the left hand side, if I'm to prove the left hand side, which is equals to what? To sine 2x over 1 plus cos 2x. Then I ask myself, do I locate any double angles there? Yes. So I'm locating double angles. The double angle is 2x, 2x. And then do I locate any compound angles? The answer is no. So if I don't have any compound angles, but I have double angles, then I'll have to use the double angle identities. So immediately I have to change this to its identity first. So I have this will be equals to sine to 2 sine x cos x. This will be over 1 plus. Now the cos identity has 3 identities. The double angle for cos has 3 identities. But which of the 3 will I have to use? So in this case, the identity that I need to use is the identity that will give me cos, the denominator. So on the denominator, if it's cos, since I know sine over cos from my quotient identity, which gives me tan. Remember, tan theta equals to sine theta over cos theta. So that is where I'm leading to. So if for me to have cos on the denominator, so I'll change that to the cos identity, which will be, in that case, I'll put it in brackets, which will be 2 cos squared x minus 1, something like that. Then the next thing that I have to do is to open that bracket and then collect my like terms, put like terms together. So I have 2 sine x cos x over, okay, over, that is what, 1, let me bring 1 out, minus 1 plus 2 cos squared x. Okay, fine. So the 1 and the 1 will go. Then I'll be left with what? 2 sine x cos x over, what is that? 2 cos squared x. Okay, I'm looking at 2 sine x cos x over 2 cos squared x. So to simplify, since I have a single term or one term on the numerator and one term on the denominator, then I can cancel. I can cancel 2 with 2, but then sine cannot cancel with cos. So I'll leave sine on the numerator, sine x, but cos can cancel with one of the cos's. We'll be left with is 1 cos. Then since you have sine over cos x, then this from the quotient identity is equals to tan x, which is equals to the right hand side, and then you've proven.